Okay, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. How's everyone? Good. This is our 11th week for DCE 6953. The last topic that we had discussed was on discriminant analysis. And today we are going to venture to another topic on ANOVA. But this is not one-way ANOVA. This will be factorial ANOVA. I mean, extension to the one-way ANOVA. Then we go for factorial ANOVA. And inshallah, next week we will continue for another topic also related to ANOVA, but that will be repeated measure ANOVA. And if time permit, I will also discuss or expose you to the MANOVA, multivariate analysis of variant. I mean, there are various variation of ANOVA, analysis of variant. So in 5950, we started with one-way analysis of variant. So today we are going to discuss on factorial ANOVA. Next week will be on repeated measure ANOVA. And maybe if we have the time, then we go for MANOVA. That will be the last ANOVA to be discussed. And the last topic to be discussed for this subject will be SEM, structural equation modeling. Early exposure to the structural equation modeling. We will not able to cover all, but we just expose you to the first and the second stages in SEM analysis. And we have another stage which will be first will be CFA, confirmatory factor analysis, and then measurement model, and the last will be structural model. I mean, the structural model will not be covered in this subject, but if you're interested, of course, but that will be the gist of SEM, because the first two stages in SEM analysis will be considered as just data preparation, to prepare your data for SEM analysis, but the actual analysis will be done in the third stage. That will be to answer your objective and also to answer your hypothesis. Oh, we still have more coming. Okay, get ready, everyone. We want to take our picture for the attendance, pictorial attendance. We have two forms of our attendance. One will be through our Google form, and this will be the second form, which will be the pictorial pictorial attendance. Okay, get ready. Oh, still quite a number of our friends still haven't switched on the camera yet. Okay, get ready. 1, 2, 3. Okay, so we have only one panel there. And there will be no second panel. Only one panel cover for the whole class for DCE 6953. All right. So any question on the last topic? So for the final exam, we will start with logistic regression, and then we continue with also include discriminant. And our topic today, which will be on factorial ANOVA, and then our topics next week will be on the repeated measure ANOVA, and finally will be structural equation modeling. I mean, we have basically 5 topics, or maybe if we have the time, we also expose you with the MANOVA, but MANOVA will not be included in the final exam because that will be just exposure. Okay, no question? Okay, if there's no question, let's go with our topic today. Okay, topic is factorial analysis of variant. Okay, if you can recall, for one-way analysis of variant, we have only 2 variables in the analysis, and that 2 variables include IV and DV, where the DV will be interval or ratio scale. The IV is either nominal or ordinal, where K must be more than 2, because if K equal 2, that will be independent sample t-test. But if K is more than 2, then we go for one-way analysis of variant. Okay. What about this factorial ANOVA? Okay. When we have one-way analysis of variant, for sure there should be two-way analysis of variance, three-way analysis of variance, four-way analysis of variance, is that right? Okay, now all these 2, 3, 4 ways analysis of variance will be combined together to form this factorial ANOVA. That means factorial ANOVA include two-way analysis of variance, three-way analysis of variance, four-way analysis of variance, dot, until whatever the number of ways analysis of variance. So what is the difference between one-way and factorial ANOVA? So the main difference here will be, we are talking about number of independent variable. Number of independent variable. Regardless of whether it is one-way or factorial ANOVA, you have only one DV, and that DV, the requirement retain that will be interval or ratio, but the difference will be number of IV in the analysis. If you have one IV, and we call that as one-way analysis of variance, but if you have 2, 3, 4 or more, then you call that, you group them under one topic called factorial ANOVA. That means you can have 2 independent variable, 3 independent variable or more. That will be the main difference between the one-way and factorial ANOVA. Okay, when we go for this factorial ANOVA, the advantage is if you were to compare by doing individual one-way analysis, that means DV and X1, DV and X2, DV and X3. That means if you were to run individual one-way analysis of variance, you can only test the effect of that one factor that is your independent variable. You can test only the effect of that factor on the DV. That means we are comparing whether there is any significant difference in your Y among the groups of IV. That will be the only thing that we can do if we were to run, let's say, Y on X1, Y on X2, Y on X3. But if you combine X1, X2, X3 in factorial ANOVA, the advantage is, in addition to testing the effect of that factor, you can also test the interaction effect. The interaction effect between the IVs on the DV. That means you have one additional analysis that we can extract from the result, where we are testing on the interaction between the IVs. That means between X1 and X2, X1 and X3, X1, X2 and X3. That means we can test the interaction effect. But we cannot test the interaction effect if you were to do the individual one-way analysis of variance. All right, so that will be the advantage when we go for factorial ANOVA as compared to individual one-way analysis of variance. The advantage is we can test on the interaction effect. Okay, let's go for the material here. So this factorial ANOVA is actually just extension to your one-way analysis of variance. I mean, instead of only having one IV, now you can have more than one IV, extension to one-way analysis of variance. So it involves one dependent variable. I mean, a dependent variable is still only one, limited to only one DV. But if you go for MANOVA, that one you can go for more than one DV. If you go for MANOVA, I mean multivariate analysis of variance. But if you go for factorial ANOVA, the DV is only one, limited to only one. And your IV can be more than one, can be 2, can be 3, or whatever the number of factors that you are interested to test in the factorial ANOVA. The purpose here will be, we want to test the mean effect as well as the interaction effect. The mean effect is the effect of the factor on the DV, the individual factor. The mean factor here will be your independent variable, factor 1 on DV, factor 2 on DV, factor 3 on DV. In addition to that, you can also test on the interaction effect of the IVs on the DV, interaction between the independent variable on the dependent variable Y. Okay, if you have two factors, then you can test for two mean effect of factor 1, mean effect of factor 2. Right? In addition to that, you can also test for the interaction effect between X1 and X2. If you have two independent variables, two factors, so two mean effect plus one interaction effect. But if you have more than two, then you can have several interaction effects. x1 on x2, x1 on x3, x2 on x3, x1, x2, and x3. I mean, combination of the interaction effect between the IVs or between the factors. That will be basically what we are looking for when we go for factorial ANOVA. Requirement: the DV must be interval or ratio, and your IV must be nominal or ordinal. In this case, it doesn't matter. You can have the IV can be 2 categories or can be more than 2 categories, because when we go for factorial ANOVA, you can have 2 or more than 2 categories for your independent variable. Right? That will be the advantage. I mean, if it is only 2 categories for one-way analysis of variance, I mean, that will be not relevant, because if it is only 2 categories, you go for independent sample test. But for factorial ANOVA, your independent variable can consist of 2 categories or more than 2 categories. Okay, assumption. Okay, since ANOVA fall under parametric statistic, therefore the first assumption that you need to fulfill will be assumption on normality for each of the level of the factors. I mean, we need to make sure that the distribution for the DV must be normal for each of the factor. Okay, that will be. But in case, okay, the note there. However, with moderate to large sample size, a non-normally distributed distribution may also yield a reasonable accurate result. I mean, if you have quite a big number of sample, then you should, I mean, even though it doesn't meet the assumption of normality, you can still apply for factorial ANOVA, and you should be able to get the pretty good accurate result for the analysis. Okay, the second assumption that we need to fulfill here will be the population variance for the DV are the same for all levels for the factors. I mean, we are talking about the equality of variance assumption as what we did earlier for one-way analysis of variance. I mean, the population variances for the DV are equal for all the level of the factors. Okay, and finally, the last the last assumption that we need to fulfill in order to run for this factorial ANOVA will be cases represent random sample from the population, and the score for the DV must be independent of each other. But that last assumption, we cannot test using SPSS, but that will be based on your methodology. If your methodology is right, then it meets that assumption. If the methodology is not right, then it violates the assumption. You can only test for assumption number 1 and assumption number 2. Okay, next. Okay, what to expect? I mean, in order to understand this factorial ANOVA, what is it that I need to understand? Okay, the one that we need to understand will be, first of all, ANOVA will always be inferential statistic. When we say inferential statistics, that means it involves testing for hypothesis. When it involves testing for hypothesis, did we record our session? Oh yeah, we record a session. Okay, when it involves testing for hypothesis, that means we need to follow the 5-step procedure as usual, from 5950 now until 6953. Right? The 5-step, as we can recall, step number 1 will be state HOHA. Step number 2 for manual calculation will be calculate your test statistic. Step number 3 will be the determine the value. Yeah. Step number 4 will be decision. Step number 5 will be conclusion. I mean, here, the first thing that we need to know about factorial ANOVA will be the 5-step procedure in testing for hypothesis. I mean, here, if you have 2 independent variables, or if you have 2 factors, I mean, we have 3 hypotheses that we can test. Hypothesis for the first factor, hypothesis for the second factor, and hypothesis for interaction between factor 1 and factor 2. I mean, it's not only one hypothesis, but you have the number of hypotheses to be tested depend on the number of factors that you have in that analysis. That will be step number 1. Step number 2. Okay, just for you, just to remind you, in this case, similar to what we did for multiple linear regression, we also it will also involve manual calculation for our factorial ANOVA. I mean, the expectation is everyone should be knowledgeable on how to run the manual calculation for this analysis, which is factorial ANOVA. That means step number 2, we are going to calculate our F ratio. That means if you have 3 hypotheses, that means we need to calculate 3 F ratio. And then step number 3 will be we determine critical value. And then step number 4, as usual, will be we just need to compare F calculated against F critical to make our decision. And our decision criteria is similar to what we did all this while. If your F calculated is bigger than or equal to F critical, reject HO. F calculated less than F critical, fail to reject HO. See, it doesn't change. It will maintain from the beginning until now, right? And until the end of our discussion. Okay, and then finally, the last step will be conclusion. That will be the 5-step procedure in testing for our hypothesis. And for two factors in the factorial ANOVA, so we have 3 hypotheses to be tested, and we should have 3 F ratios. And then from there, at the end, we should be able to have 3 conclusions. Conclusion for factor 1, conclusion for factor 2, and conclusion for interaction. Okay, that will be, we will go for both manual calculation, SPSS plus SLT. SLT also provide the template where it will be able to do the calculation and proceed with the rest of the analysis. Okay, in addition to that, after we have done the testing for the hypothesis, then we may want to proceed, especially when you reject the null hypothesis, we want to explain how big is the difference. If you want to explain how big is the difference, then we proceed with effect size. And the effect size of concern here will be not eta squared, but here will be partial eta squared. Why partial eta squared? Because we have several factors that we are testing. The individual, the main effect, the 2 main effect, plus the interaction. So I mean that's why they call it as not eta squared, but partial eta squared. And that will be the what to expect when you go for factorial ANOVA. Okay, now the 5 step in testing for hypothesis. 5 step. This is just to further reinforce what we mentioned all this while. Step number 1, state HOHA. Step number 2, calculate our test statistic. I mean, the test statistic here will be the F ratio. And then step number 3, determine critical F. Step number 4, decision. And step number 5 will be our conclusion. That will be the 5-step procedure. Okay, step number 1. Step number 1. Okay, since we are supposed to be for 2-factor opinion analysis, we are supposed to have 3 hypotheses. That means 3 null hypotheses and 3 alternative hypotheses. So what are the hypotheses? Okay, for factor 1, we just write like what we did for one-way analysis of variance. The HO will be mu1 equal mu2 if you have only 2 factor, 2 categories, or if you have more than 2 categories, you can just continue equal mu3 equal mu4. That will be the null hypothesis. The alternative hypothesis, not all means are equal. I mean, identical for factor 1 and factor 2, we have the same format for the null and alternative hypothesis. HO, mu1 equal mu2 equal mu3, dot. And then the alternative hypothesis, not all means are equal. That will be the 2 factors. For the interaction, we just write as HO, mu ij equal mu ij prime. I mean, for the interaction, we just write in the format mu ij equal mu ij prime for the null hypothesis. For the alternative hypothesis, we just need to write as mu ij not equal to mu ij prime. I mean, the mu ij equal to mu ij prime, the meaning is there is no significant interaction effect. But if there is significant interaction effect, then that will be what we mentioned, what we write as the alternative hypothesis, mu ij not equal to mu ij prime. That will be the 3 hypotheses to be stated in step number 1. Okay, step number 2. Okay, step number 2, our calculation. Okay, get ready with the calculator. All right, our calculation. Okay, now the first thing that we need to calculate will be we need to calculate sum of squares. Okay, the sum of squares that we need to calculate include sum square total. You see, very similar to what we did for one-way analysis variant. It's just simply your sum square for y, where the formula for sum square total is just simply summation y square minus summation y bracket square divided by n. the normal sum square for y, right? That will be, and that is also what we have done for regression. When we calculate for sum square total, we use the same formula, summation y square minus summation y bracket square divided by n. But that is meant for simple linear regression, not for multiple linear regression. Okay, next will be sum square between for factor 1. Sum square between for factor 1 as what we did for simple linear, for one-way analysis of variant. Summation ti square divided by n minus summation y bracket square divided by a big N. I mean, since we have two factors, so one we call that as I for factor 1, j for factor 2, right? J for factor 2. Last time when we discussed for one-way analysis of variant, the formula to calculate for sum square between was summation tj square divided by n, remember, minus summation y bracket square divided by big N. But here we have I and j. Okay, that will be factor 1. Factor 2, see the same format for the formula. Summation, instead of I, now we use j. Summation tj square divided by n minus summation y bracket square divided by big N. That will be sum square between for factor 2. And we have I and j, 1 and 2. And then sum square between for interaction. I mean, we have between for factor 1, between for factor 2, and between for interaction. In order to calculate sum square between for interaction, the formula is summation of tij square divided by n minus summation y bracket square divided by big N. And then we need to include additional element here, minus sum square between for factor 1 plus sum square between for factor j. And I mean, that will be the formula to calculate for sum square between for interaction. I mean, we have the format for the first element will be very much similar to the format for factor 1, factor 2, but we have ij, but we include minus within bracket sum square between for factor 1 plus sum square between for factor 2. And finally, we need also to calculate for sum square within. Sum square within. So that means the difference between one-way analysis variant. In one-way analysis variant, we have only sum square between, and then only one sum square between, and then sum square within. Is that right? But here we have to split the sum square between for factor 1, factor 2, and interaction between factor 1 and factor 2. Okay, once we have this 5 sum square total, sum square between for factor 1, sum square between for factor 2, sum square between for interaction, and finally sum square within, then we can calculate the degree of freedom, because in order to calculate the mean square, we need to have the degree of freedom. Okay, now degree of freedom for factor 1 is just simply I minus 1. That means number of category for factor 1 minus 1. And then for factor 2, the same thing, but instead of I, we use j. J here refer to number of group for factor 2 minus 1. And then for the interaction will be I minus 1 multiplied by j minus 1. That will be the degree of freedom for interaction. And then degree of freedom for within is summation of nij minus 1. Summation of nij minus 1. And then for the total will be n minus 1. That will be the 5 degree of freedom that we need to calculate before we can proceed to calculate for mean square. Right? Okay, now after we have calculated for the sum square degree of freedom, okay, now we should be able, we can straight away present the summary ANOVA table. As usual, we have source, sum square, degree of freedom, mean square, and F. Okay, the source will be between the between group for factor 1, between group for factor 2, between group for interaction, and within, and finally total. And then we have sum square between for I, sum square between for j, sum square between for ij, the interaction, sum square SSW for within, and SST for total. And then degree of freedom is I minus 1, j minus 1, I minus 1 multiplied by j minus 1 for the interaction, and for the within is summation of nij minus 1, and for the total is n minus 1. And then the next step, we just need to calculate for mean square. So mean square between for I, mean square between for j, and then mean square between for ij, and then mean square within. And finally, what we need is only three F ratios, yeah, right? In order to get the 3F ratio, the first F ratio will be for factor 1, which will be mean square between I divided by mean square within. That will give you F for factor 1. F for factor 2, Fj, will be mean square between for j divided by mean square within. That will give you Fj. And then Fij will be mean square between for ij divided by mean square within. I mean, this will be the 3 F ratios that we need to calculate before we can make our to proceed with the critical value, and further after that will be making our decision. Okay, that will be what we should be able to complete in the summary ANOVA table, where we have the source, sum square, degree of freedom, mean square, and F. But for the F, we need to have only 3. 3 for factor 1, factor 2, and interaction. Okay, next will be to determine critical value. In order to determine the critical value, as usual, for the F table, we need to have 2 degree of freedom. The 2 degree of freedom come from I. That means for factor 1 will be degree of freedom for I and degree of freedom for within. And for factor 2 will be degree of freedom for J and degree of freedom for within. And then degree of freedom for Ij will be, for the critical value, not degree of freedom. The critical value for interaction will be degree of freedom for Ij and degree of freedom for within. That means the denominator will always be degree of freedom for within. But for the numerator, the one on top, the degree of freedom for the top will be degree of freedom for the factors as well as for the interaction. Okay, next will be our decision. Decision will be the same decision criteria that we have applied earlier. For manual calculation, I mean, we are discussing on manual calculation currently. So we just compare the F calculated against F critical. If it is bigger than or equal to, reject HO. If it is less than, then fail to reject HO. That will be for manual calculation. But if you were to run SPSS, then for SPSS, we don't compare F calculated against F critical, but instead, we just need to compare a significant F from our SPSS output against alpha. Our decision criteria, if it is less than or equal to, reject HO. If it is bigger than, then fail to reject HO. That will be step number 4, our decision. And finally, for the conclusion, if we were to reject the null hypothesis, we say there is significant mean or interaction effect on the DV. That will be, if we were to reject, I mean, there is significant mean effect of factor 1, mean effect of factor 2, and mean effect, and also interaction effect between I and J on the DV, if we were to reject the null hypothesis. Otherwise, if we were to fail to reject the null hypothesis, then it's just the opposite. I mean, there is no significant mean effect or interaction effect on the DV. That will be what to expect for the 5-step procedure in testing for the hypothesis. Okay, next will be for the post hoc comparison. For the post hoc comparison, we can use 2 key HSD, honestly significant difference, as what we did for one-way unlisted variant. One-way unlisted variant. So as usual, we just need to calculate HSD, where if you recall, in order to calculate HSD, we need to have Q and then multiply that with square root of MSW, I mean mean square within, for the respective effect of concern, divide by N. Divide by N. Criteria for the difference: significant difference if mean difference is bigger than HSD, and no significant difference if the mean difference is less than or equal to HSD. HSD is the one that we need to calculate before we can make our decision. HSD become the cutoff point, the cutoff point to decide whether the difference is significant between the group or the difference is non-significant between the two groups. Okay, finally, the effect size. For the effect size, remember, we are calculating partial eta squared. We don't calculate eta squared, but we calculate partial eta squared. Okay, for partial eta squared, the value of, as what we have discussed earlier, ranges between 0 to 1. We can explain the eta squared in terms of size. If we were to explain in terms of size, we can use the one given by Cohen. Less than 0.01, we consider it as trivial. If it is 0.01, small. 0.06, medium. 0.14, considered as large effect size. Or you can explain by the percentage of variance in your DV that is explained by that particular mean effect or interaction effect. Right? Mean effect or interaction effect. But here we are excluding the other mean or interaction effect. I mean, we are focusing only mean effect 1, factor 1, mean effect for factor 2, or mean effect of the interaction. I mean, by excluding the other mean effect. Okay, the formula to calculate for the partial eta squared. Okay, if you observe, if you were to observe on the screen, what is the difference in the formula for eta squared as compared to partial eta squared? What is the difference?
For eta squared, we just use SSB divided by SSW. But for partial,
SSB divided by SSW or SSB?
ST, yeah, SST.
Yeah, we divide by SST because we have only one factor. That means we just need to divide sum square between divided by sum square total. That will give us our eta squared. But since we have factor 1, factor 2, and interaction, I mean, in order to calculate for the partial eta squared, we don't divide by sum square total. I mean, we don't divide the sum square between for each of the factor or interaction with sum square total, but instead we just add that we divide by sum square between for that factor plus sum square within. That's why we call that as partial eta squared. We don't divide by total, but we divide by sum square between for that factor plus sum square within. Okay, so for factor 1 will be SSBI divided by SSBI plus SSW. And then for factor 2 will be the same thing. That means we just divide sum square between for J divided by SSBJ plus SSW. And for the interaction will be SSBIJ divided by SSBIJ plus SSW. That means when we calculate, we don't divide by sum square total, but instead we just divide by sum square between plus sum square between for that factor plus sum square within. If it is only one factor, that means sum square between plus sum square within, of course, will be equal to sum square total. Is that right? If it is only one factor, sum square between plus sum square within will give you sum square between sum square total. But here, since we have factor 1, factor 2, and interaction for two factor analysis, then we divide by just the effect of that factor, and then plus the sum square within. Okay. Okay. Now that will basically what to expect for factorial ANOVA. I mean, we have discussed when to apply for factorial ANOVA, what is the difference between one way as compared to factorial ANOVA, and then we discuss about the requirement, the assumption, and also what we need to understand about factorial ANOVA, the 5-step procedure, and we also follow through on the manual calculation, the step-by-step calculation in order to derive the F ratio for factor 1, F ratio for factor 2, and F ratio for interaction until our conclusion. And then we also look at the post hoc comparison. This post hoc comparison is only relevant for if you have more than 2 categories. If it is only 2 categories, do we need to run post hoc comparison? No need, right? Understood. If there is different, I mean the 2 group is considered to be significantly different. But if you have more than 2, let's say 3 categories, I mean the difference may be attributed by group 1 and group 2, or group 1 and group 3, or group 2 and group 3. But if you have only 2 groups, if the difference is significant, I mean significant, no need to proceed further. So it's only relevant if you have more than 2 categories for your independent variable or factor. Okay. Any question before we start with before we proceed with this example? Faiza, sihat? Sihat ke tak? Sihat kena ngangguk lah. Okay, any question before we proceed? So basically, it's not much difference, yeah, right? There are some differences here and there, but just to accommodate for extra number of factors in the analysis for ANOVA. So where we call that as factorial ANOVA. Okay, if there's no question, then let's go for the example. The example here will be, in a study to compare job stress. The job stress is our dependent variable among teachers who were under principal with different gender and leadership style. I mean, we want to compare the teacher stress, but the teacher stress it's not based on their own factor, but this is factor based on principal where they are working under the principal, different gender, I mean male and female, and leadership style. I mean we have three different leadership styles. We want to test whether there is any significant difference in job stress of the teachers if they are working under male or female teachers, principal, or whether they are working under different leadership style. And then also we want to look whether there is any interaction effect between gender and leadership style of the principal, whether it has any effect on the teacher's stress level or teacher's stress score. That will be basically what I'm interested in. Data were collected from a randomly selected sample, and the data will be given in the next slide. Okay, question number 1. Test the significance of the two mean and interaction effect on job stress at 0.05 level of significance. I mean, we are supposed to test 3 different hypotheses. Hypothesis for factor 1. Factor 1 will be gender. Factor 2 will be leadership style. And factor 3 will be, not factor 3, but the next will be interaction between gender and leadership style. That will be the interaction. Okay, and then number 2, if appropriate, apply post hoc comparison to identify pairs of group that is or are significantly different. And then number 3, calculate and interpret effect size for each of the effect. I mean, in this case, we are calculating for partial eta squared. Okay, now that will be the 3 questions. First, we are going to test for the hypothesis. Second, if it is significant and if it is more than 2 categories, then we need to proceed with the post hoc comparison. And finally, also normally when we go for our data analysis, if it is significant, then we also want to look at the effect size. We also want to elaborate further on the effect size. Okay, that data set. So we have this autocratic, democratic, and laissez-faire. I mean, these are the 3 leadership styles for the principal: autocratic, democratic, and laissez-faire. And then we have male and female. And for each subgroup, we have 10 cases. Yeah, 10 cases. I mean, we have 10 teachers working under male autocratic principal, another 10 teachers working under female autocratic principal, another 10 teachers working under male democratic principal, another 10 teachers working under female democratic principle, and finally we have another 10 and 10 for male and female under laissez-faire leadership style for the principle. I mean, altogether we have this total sample size in this case will be 60. So 10 plus 10 plus 10 plus 10 plus 10 plus 10, that will be 60. And for each cell, we have 10 cases. That will be our data set for this analysis. Okay, and based on that data set, what we need to do will be, if we were to work on our manual calculation, we need to come up with the summary statistic for the data. Summary statistic for the data. So what we need to calculate here will be, first of all, we need to know what should be N for each of the group or each of the cell. So in this case, we have all are 10, right? And then we need to know summation Y for each of the group. So we have 758 for the first group, 865, 691, 719, 709, and 775. That will be the summation Y. I mean, the total for the dependent variable for each of the cell. Okay, so we have 6 categories or 6 group altogether or 6 cell. And then summation Y for each of the categories. or each of the group. Okay, and then that will be, and then y bar, I mean mean for y for each of the cell or each of the group. So we have 75. I mean, since we have only 10, I mean, just go to move the decimal place to the left one step. So we have, instead of 75.8 as 758, now we have 75.8 as the mean. Okay, so that will be the summary statistic required in order to calculate, to proceed with the calculation. In addition to that, to make life easier, then we go for this. We go for the calculate for the overall. For the overall, summation y will be, I mean, we just add everything here. I mean, 758 until 775, that amount to 4,517. And summation y square will be, I mean, we just need to add all the 6 cells for the summation y, that amount to 345,400. 345,029. And then for male we have 30 cases here, right? So we have 10, 10, and 10. So we have 30 cases. And summation y will be, we just need to add this plus this plus this. It amount to 2,158. For female, we have another 30 cases. I mean, this, this, and this. So, and then for the summation y, we just add the summation y for the only for female, which amount to 2,359. This will be for factor 1. For factor 2, we have autocratic. We have 20 cases. Summation y will be this plus this, which is equivalent to 1,623. And then for democratic, another 20 cases. Summation y will be 691 plus 719. That amount to 1,410. And finally, for the laissez-faire, we have another 20 cases, and summation y will be 1,484. I mean, this will be the overall summary statistic that will be required to facilitate our calculation for factorial ANOVA. I mean, first of all, we get for each of the cell, and then we go by the factor. I mean, overall, plus we go by the factor. With all this information, then we should be guided in doing our calculation. So any question about the summary statistic? If we go slow and steady, if we follow through the step-by-step procedure, we should be able to come up with the summary statistic on the right, for the overall, for summary for factor 1, and summary for factor 2. Okay, next will be, okay, step number 1. Okay, in order to run for this analysis, step number 1 will be when we want to state HO/HA. So for factor 1, gender, HO will be mu1 equal mu2 against the alternative hypothesis, mu1 not equal to mu2. That means you're saying that there is a significant difference in job stress among teachers working under male and female principal. That will be hypothesis number 1. Hypothesis number 2 will be for leadership style of the principal. HO, mu1 equal mu2 equal mu3 against the alternative hypothesis, not all means are equal. That will be for factor 2. For interaction will be HO mu ij equal mu ij prime as compared to HA mu ij not equal to mu ij prime. That will be the 3 hypotheses to be tested in this analysis. For factor 1, gender, factor 2, leadership style, and then finally interaction between gender and leadership style. Okay, next we are supposed to calculate the 5 sum square. We start with sum square total, and then we have another 3 sum square between for factor 1, sum square between for factor 2, sum square between for interaction, and finally sum square within. Okay. The calculation will be, okay, we get the summary statistic for the overall plus factor 1 and factor 2 on the right, so that will facilitate us in our calculation. Okay, for sum square total, I mean, we go for the overall. I mean, the formula is just simply summation y square minus summation y bracket square divided by n. So what is summation y square? Summation y square is 345,029, and then summation y is 4,517. So we just plug in the value, 345,029 minus 4,517 square divided by total sample size 60. So in this case, if we were to solve for this, the value that we'll be getting for sum square total is 4,974.1833. That will be sum square total, right? I mean, if you were to do the calculation, provided that no careless mistake, by right, you should be able to come up with the accurate answer. But remember, while doing the calculation, especially for the exam, you need to go at least 5 decimal places. The final answer depend on, in this case, this is not the final answer because the final answer will be the F, the F ratio. I mean, that will be the final answer. Then depend on what is required, maybe 2 decimal places or 3 decimal places. So we just trunken the result accordingly. Okay, that settle for sum square total. Very straightforward here, right? Any question for that? Sum square total? Okay, that means we just focus on the right for the summary, just for the overall. That means n equals 60, summation y. Also we have summation y square. Okay, next we want to calculate for sum square between for factor 1, which is gender. For factor 1, the formula is summation ti square divided by n minus summation y bracket square divided by big N. Okay, big N will be for each of the cell, for each of the group. Then that means for gender, we have 30 and 30, right? 30 and 30, and the big N will be 60. And then the total will be total for the first group will be for gender. For male will be 2,158. For female will be 2,359. So we just need to square total for the first group, which is for male, 2,158, which is this one here, 2,158 square divided by the small n, which is 30, plus 2,359 square divided by 30. That will be summation ti square. Because we have only 2 groups, therefore we need to have group total for group total 1 square divided by sample size for group 1 plus group total 2 square divided by sample size for group 2. And then the second element, summation y bracket square divided by n, is we have already done the calculation earlier, is that right? I mean, if we were to calculate this time, make sure the answer should be the same as what we did earlier for the second element, which is summation y square divided by big N. So in this case, 4,517 square divided by 60. And if we were to solve for this, what we get will be 673.3499. And that will be the sum square between for gender. Sum square between for gender is 673.3499. Don't say 673.3499. That is wrong. After the decimal, we just spell the individual number. So 673.3499. That will be our sum square between for male. For gender, not for male. For gender, the first factor. Okay, next will be sum square between for J, which is for leadership style. For leadership style, that means we have 3 groups. Therefore, we should have 3 group total. So in this case, will be the 3 group total will be 1,623, 1,410, and 1,484. So we just do within the bracket. 1,623, that means this is for the autocratic, square divided by 20, plus for the democratic, 1,410 square divided by 20, and then plus the last group will be for laissez-faire, 1,484 square divided by another 20, and then minus the same value as what we had earlier, 4,517 square divided by 60. And if we were to solve for this, the answer will be 1,169.4333. That will be sum square between for leadership style. But remember, not the leadership style for the teachers, the leadership style for the principal under which the teachers are working. Okay, that will be the third sum square, and the second sum square. the third sum square total, sum square between J, sum square between I, sum square between J. And now we want to calculate for sum square between IJ for the interaction. Okay, for the interaction, what we need to do will be, we can use the total from male, from gender, male, we have 3 group, and then female, we have another 3 group, or we can use the total, the group total for autocratic, where for the we have 2 group, and then democratic, we have 2 group, and then laissez-faire, we have 2 group. And in order to solve for summation Tij squared, I mean Tij squared refer to the individual group total. Altogether, we have 6 group, either the 6 come from 3 group from male, 3 group from female, or the 6 group come from 2 group from autocratic, another 2 from democratic, another 2 group from laissez-faire. I mean, the value will be the same. So which is equivalent to, in this case, okay, let's say we refer to the, for gender, I mean, the first 3 come from male, 758 square divided by 10 plus 600, or this, in this case, we are referring to this one, we are referring to the autocratic, because we are using this one. Okay, 865 square divided by 10, and then plus 691 square divided by 10, plus 719 square divided by 10, plus 709 square plus, divided by 10, and then finally plus 775 square divided by 10. I mean, altogether we have 6 cells, 6 group, right? 6 group. I mean, the sequence doesn't matter as long as we have all the 6 group included within the bracket. And then minus, summation y squared divided by n, which is the same value that we have earlier, and then minus sum square between for factor 1, which is gender, plus sum square between for factor 2, which is leadership style. I mean, that will be, oh, I think some, oh, we have that. Okay, okay, that's right. Okay, if we were to solve for this, the sum square between for the interaction is 156.1001. 1001 malam. Special number kan. 156 1100 malam. Okay, so that will be our sum square between for interaction between gender and leadership style. And is there any additional sum square that we need to calculate? We have done sum square total. We have done sum square for gender, sum square for leadership style, sum square for interaction, and what else?
Sum square within.
Yeah, we have one more that we need to calculate, sum square within, where sum square within equal sum square total minus sum square between for factor 1 minus sum square between for factor 2, and then minus sum square between for interaction. So we just plug in all the sum square into here. So sum square total, that means if you were to minus sum square total minus the rest of the sum square, what we get in this case will be 2975.3, and that will be sum square within. Okay. And then once we have already calculated for the sum square, the 5 sum square, you don't have to show this how to calculate for the degree of freedom. We straight away can proceed for the, if you don't want to don't want to show, it doesn't matter, you can just proceed. But if you want to show, then for factor 1 will be I minus 1. So for factor 1, which is gender, we have 2 categories, right? So 2 minus 1 will be 1. For factor 2, which is leadership style, J minus 1. So J, we have 3 categories. So 3 minus 1 will be 2. For the interaction, I minus 1 multiplied by J minus 1. So I minus 1 will be 1. And then J minus 1 will be 2. So 1 multiplied by 2 will be 2. Okay. Next will be for sum square within, summation Nij minus 1. And I mean for each cell, remember, we have 6 group altogether. We have 6 cells. So Nij refer to, let's say, male autocratic, female autocratic, the second, and then male democratic, female democratic, male laissez-faire, and female laissez-faire. For each group, we have 9 cases, and we have 10 cases here, right? So 10 minus 1 will be 9. So 10 plus minus 1, which is 9. That means 9 plus 9 plus 9 plus 9 plus 9, that amount to 54. That means for each cell, we just get the n, the sample size, the small sample size, and then minus 1, and we get the total for all the 6 cells. And this, in this case, it happened to be all equal 10, 10, 10, 10, 10. Therefore, we have 9. When 10 minus 1 will be 9, so 6 and 9 multiplied by 6 will be 54. Okay, that will be for the sum square within, and sum square total is just simply big N minus 1. So 60 minus 1 will be 59. That will be the degree of freedom for all the 5 source of opinion in the opinion summary ANOVA table. So we prepare the summary ANOVA table. We have gender, leadership style, interaction, within, and total. For the first one will be sum square between for gender. We have already calculated 673.350. Sum square between for leadership style 1169.433. Sum square interaction 156.1. Within 2975.3, and total 4974.183. That are the 5 sum of squares. And then for degree of freedom, we have already calculated. For gender, we have only 1. Leadership style, we have 2. Interaction 2. Within 54. And then for total 60 minus 1, which is equivalent to 59. Or you can just simply add the degree of freedom for the 4. So 1 plus 2 plus 2 plus 54, that also amount to 59. I mean, you can use the formula n minus 1 or degree of freedom for factor 1 plus degree of freedom for factor 2 plus degree of freedom for interaction plus degree of freedom for within. That also amount to some degree of freedom for total. Okay, once we have the 2 column, sum square and degree of freedom, then easily with our calculator, we should be able to calculate for mean square. I mean, mean square for gender will be 673.350 divided by 1. I mean, it will be the same value. For mean square between for leadership style, 1169.433 divided by 2, that will give us 584.717. Interaction, sum square between for interaction, 156.1 divided by 2, that will give us 78.050. And finally, mean square within, which is 2975.3 divided by 54, that will give us 55.098. That I mean, once you get this mean square, then we should be able to proceed to calculate for the F ratio. The F ratio for gender will be 673.350 divided by 55.098. That will give you 12.221. That will be the first F ratio for gender. F ratio for leadership style will be 584.717 divided by 55.098. That will give us 10.612. And then for interaction will be 78.050 divided by 55.098. That will give us 1.417. 1.417. I mean, now we have all the 3 F ratio. F ratio for gender, F ratio for leadership style, and finally F ratio for interaction. Okay, that will be step number 2, where we calculate for the test statistic. I mean, even though if we look at the step, it's quite, I mean, we have several stages that we have to go through, but if we get the concept right, easily we should be able to work on the calculation. Okay, next, we want to proceed with the critical value. Okay, the critical value, everything will be degree of freedom for the factor and degree of freedom for within. I mean, for gender will be 1 and 54. Leadership style will be 2 and 54. And interaction will also be 2 and 54. Okay, that will be the 2 degree of freedom required before we can derive the critical value from the F table. So for gender will be 1 and 54 at 0.05 will be 4.03. For leadership style, 2 and 54, 3.18. And then for the interaction, the same thing, which is 2 and 54, will be 3.18. That will be the two critical value required in order to for us to make our decision in step number 4. This is step number 3. So step number 4, decision and conclusion. For gender, that means here you are talking not the teachers, the gender for the teachers, but gender for the principal. Okay, for principal gender. Okay, the F calculated is 12.221, and F critical is 4.0. 4.0 earlier was 4.03 or 4.02. Okay, please check.
Oh, sorry.
03, okay, 4.0. I mean, the earlier slide should be 4.03. Okay, now, so for gender, since F calculated 12.221 bigger than F critical 4.02, therefore, our decision will be reject HO. Yeah? Reject HO. When we reject HO, what can we conclude? There is significant mean effect of principal gender on teacher stress at 0.05 level of significance. That will be the first factor that we are testing. And we are testing on teachers' stress based on principal gender. I mean, whether they are working under male or female principal. It seems that it makes a difference because there is significant difference in the teachers having stress between between those who are working under male and female principal, and the difference is significant. Okay, that will be the first effect. The second main effect will be main effect for leadership style, principal leadership style. So the F calculated is 10.612, which is also bigger than F critical 3.17. Therefore, reject HO. When we reject HO, I mean, the conclusion will be there is also significant mean effect of principal leadership style on teacher stress at 0.05 level of significance. I mean, whether they are working under democratic, autocratic, or laissez-faire principle, it also makes a difference. I mean, the difference is also significant. Right, that will be the second main effect. And for the interaction, the F calculated is 1.417, which is smaller than F critical. When it is smaller, based on our decision criteria, then fail to reject the null hypothesis. When we fail to reject the null hypothesis, the conclusion here will be there is no significant interaction effect between principal gender and principal leadership style on teacher stress at 0.05 level significant. I mean, what we are saying is, I mean, if we were to compare those whether those who are working, whether they are under male or female, whether they are autocratic, democratic, or laissez-faire leadership style, doesn't make any significant difference. The difference is non-significant. But I mean, if we were to compare by the 6th group, it does not make any difference. That will be for the interaction. That will be the 3 effects that we can test based on the 2 factors in Factorial ANOVA, where we have 2 main effects. The 2 main effects in this example basically is gender, principal gender, as well as principal leadership style. And the third will be we are testing on the interaction between gender and leadership style. Okay, that will be the last step in our testing for hypothesis. So any question? Open for if there's any question that you may have. From step number 1 until step number 5, we have gone through step by step. So remember, for this topic, there will be also manual calculation. So make sure we get the concept right. We know the step-by-step procedure in doing the calculation, because in the final exam, a question on this require you to do the calculation. Okay, any question? Any question that you may have that you want to pose for clarification? Yong Jingping, is it clear so far, all the steps?
Yes, it's quite clear.
Quite clear, but remember, yes, we need to continue and follow through, review, and proceed to work on the calculation until you get the full understanding on the step-by-step procedure in the testing for hypothesis. Charlie, any question, Charlie? Okay, good. The rest, Nasiha. Nasiha, I can see your forehead. Oh, Haslinda cepat-cepat on kan dia punya kamera. Okay, Haslinda, Nasiha, any question? Is it clear? Clear. Okay, good. Well, the brightest background nampak macam Haslinda, maknanya you have good lighting system because you seem to be bright. Your environment is bright. Yang lain tu nampak kurang sikit. Okay. If there's no question, I mean, after all, if you go step by step, I mean, make sure practice. If you don't practice, may seem to be simple, but it may be difficult when we go for the actual in the exam. But if we have enough practice, I'm sure in the final exam, you should be able to work on the calculation easily. Okay. Expect to have calculation on factorial ANOVA. Of course, we don't give you big data set, but as usual, we give you small data set just for you to make sure that we get the concept right. We know the step-by-step procedure, and at the end, of course, we should be able to appreciate the how to make our decision and conclusion. Okay, if there's no question, then let's go proceed with the discussion. Okay, next will be post hoc comparison. Okay, now we have 3 effects just now, 2 main effect and 1 interaction effect. Based on the result, is there any post hoc comparison that we need to proceed on?
Yes.
Yeah. Yes. Which one?
For the second
factor. Which factor?
The second factor.
Oh, the second factor. Because it is not relevant to test to go for post hoc comparison, even though when we test for gender, it was significant, yeah, right? It was significant, but since we have only 2 categories, I mean, when it is significant, I mean, the male and female, the difference is significant. I mean, no need to proceed for post hoc comparison. But when we test for leadership style, where we have 3 categories, 3 groups, and we found it to be significant, and we want to know whether the difference is between autocratic and democratic, or autocratic and laissez-faire, or democratic and laissez-faire. I mean, if you want to know which group that make the difference, then we need to proceed for post hoc comparison. Okay, for post hoc comparison, first of all, we need to calculate HSD. Remember our 5950. Once upon a time, last semester, it's actually not far away. Last semester, we did the discussion. Okay, we need to calculate HSD. And in order to calculate HSD, we need to get Q. And where can we get the Q? From which table? From which table? Do you still remember? What is the name of the table?
Points.
Percentage point of studentized range. Right? Okay, percentage points of studentized range on page 12 of the booklet. Page 12. I mean, this booklet, the booklet that I share to other students, was developed by your group or the group before that? Is it your group when you did your 5950, or when you attend my class for 5950, I share you the soft copy of the booklet, or someone from the group prepare that soft copy for the booklet? Did I share you, or somebody from the group? I think maybe the group before that who did the soft copy. They prepared the soft copy, and I keep it and I share to the rest of the students. I think you all just benefit from the earlier groups, right? Someone from the earlier group prepare the soft copy, and alhamdulillah, we get the benefit. Okay, that will be where to get the Q. And then MSW, we need to go back to the summary ANOVA table, and then N. So in this case, N are equal. Right? We have equal number for the 20, 20, and 20. So I mean, we don't have to calculate for the N prime. So we just divide by 20. So based on the summary ANOVA table, mean square between mean square within is 55.098. This value is from your summary ANOVA table. And then N, because we have 20, 20, 20, the same number, we don't have to calculate for the N prime. So we just enter 20. And then the Q here will be, we have 3 categories. and then degree of freedom for within is 54, alpha 0.05. That means if we refer to this setting, then the Q is 3.40. Okay, let's try to check. Is it really 3.50? 3.40? 3, the column, and then you move down until you get degree of freedom 54, or you don't have 54, but we have 40 and 60. 40 and 60. So which one is closer?
40.
Okay, the number here, 354. It seems the number 3.40. Okay, 3.40. Okay, that means we go for 60, and then since we have 0.05 and 0.01, we just refer to the row for 0.05. We get the value to be 3.40. Yeah, right? That will be the Q from that table. Percentage point of studentized rate on page 12. And then when we solve for this, what we get is HSD equal 5.6433. That will be HSD. Okay, the next step will be, we need to calculate mean difference for each of the pair. I mean, the pair will be autocratic and democratic, the first pair. The second pair will be autocratic and laissez-faire. And the third pair will be democratic and laissez-faire. I mean, 1 and 2, 1 and 3, and 2 and 3. Okay, now we calculate the mean difference. So the mean for each of the group as presented there, 81.15 for autocratic, 70.5 for democratic, and laissez-faire 74.2. Okay, now the mean difference for the first pair is 81.15 minus 70.5. That will give us 10.65. And then for 1 and 3 will be 81.15 minus 74.2. That will give us 6.95. And then 2 and 3, 70.5 minus 74.2. That will give us minus 3.70. Okay, now if we look at the decision criteria, the decision criteria says we just need to compare the mean difference between the two groups for the pair against HSD. If it is bigger than HSD, the difference is significant. But if it is less than or equal to, the difference is non-significant. So in this case, for the first pair, 1 and 2, that means autocratic and democratic, where the mean difference is 10.65, which is bigger than 5.643. Therefore, we put a star. The star there indicate there is significant difference in job stress, teachers' stress between principal under autocratic and democratic. I mean, the difference is significant. The second pair, autocratic and laissez-faire, where the mean difference is 6.95, also bigger than 5.643, the difference is also significant. But the last pair between democratic and laissez-faire, the mean difference is minus 3.70. When we want to compare against HSD, we just refer to the absolute value, disregard the minus. Because if we minus the third group minus the second group, we get positive. So we just take the absolute value. But since 3.70 is smaller than 5.643, therefore we don't put a star. No star indicate the difference is non-significant. I mean, between the three pairs, 2 of them are significantly different. 1 of them is non-significantly different. So the 2 that are significantly different are between 1, autocratic and democratic. The second pair will be autocratic and democratic. That will be the second pair will be autocratic and laissez-faire, but no significant difference between democratic and laissez-faire. That will be what to expect for the post hoc comparison. Okay, now finally, before finally, any question on the post hoc comparison? This is another reinforcement of what we have learned in 5950. Right? So the steps are, first of all, we calculate HSD, which is just simply Q multiplied by square root of MSW divided by N. And then that is step number 1. Step number 2, calculate mean difference for each of the pair, between 1 and 2, between 1 and 3, between 2 and 3. And then step number 3 will be, we just need to compare mean difference against HSD, And from there, we should be able to make our decision whether the difference is significant or otherwise. But the expectation is if you reject the null hypothesis for that factor, we would expect at least one of the pair to be significantly different if we were to reject the null hypothesis. But if we fail to reject, for sure, when you run for the post hoc, none of the pair will be significantly different. Okay, that will be what to expect. So any question? Okay, clear, alhamdulillah. Okay, effect size. So we have three effect size that we need to calculate, three partial eta squared. Okay, one will be for gender. For gender, the formula is sum square between for gender divided by sum square between for gender plus sum square within. So in this case, if we refer to the summary ANOVA table, we get 673.35. That will be sum square between for gender divided by sum square between for gender, which is also 673.35, plus sum square within 2,975.3. So if we were to solve for this, what we get will be 0.185. And then based on, if we want to explain in terms of size, based on Cohen, so 0.183 is more than 0.14, is it right? More than 0.14. Therefore, we consider as large effect size. I mean, the difference in job stress among teachers who are working under male and female, the difference is big, large. Or we can interpret by percentage of variance explained. I mean, in this case, if you want to interpret by percentage of variance explained, Faiza, what can we say? In terms of size, is large. In terms of percentage of variance explained, what can we explain?
18.5%, whereas in job stress is accounted for by principal's gender.
Yes, I mean, we are saying that 18.5% variance in teachers' stress is attributed to the principal gender. The principal gender, because we are the independent variable is not the teacher, is the gender of the principal. That will be how we interpret the effect, the partial eta squared for gender, right? For gender. Second, leadership style. Okay, for leadership style, we do the same thing, the same formula, sum square between for the leadership style divided by sum square between for leadership style plus sum square within. Okay, we get the sum square between for leadership style, which is 1,169.350 divided by 1,169.350 plus 2,975.3. That will give you 0.282. The result will be seem to be higher, right? Higher. I mean, what we are saying here, still in terms of size, we consider that to be large, but this one will be comparatively larger as compared to gender, larger when we compare among autocratic, democratic, and laissez-faire principle leadership style. The size of the difference is even larger as compared to gender. Okay, if we were to explain in terms of percentage, then we say 28.2% variance in teachers' job stress is attributed by principal leadership style. And if we were to compare, this seems to be higher, right? Higher. And then for the last effect, which is the interaction, for interaction will be sum square between for interaction divided by sum square between for interaction plus sum square within. We just plug in the value 156.1 into the equation, and the answer that we get here is only 0.050. 0.050. I mean, 0.050 in terms of size is in between 0.01 to 0.06, right? So when it is in between, it doesn't reach 0.06. So what can we say in terms of size? What can we say? Is it trivial? Is it small? Is it medium? Small. Or is it large?
Small.
Yeah, it's still considered as small. I mean, this is also in line with when we test for the hypothesis, the effect is non-significant, right? And the interaction effect is non-significant, and the size of the difference is just small, which is 0.050, or only 5% variance in jobs in teacher stress is attributed by this interaction between gender and the D-shaped star. It's is considered to be small. Okay, that will be the 3 partial eta squared based on our calculation. So that will basically be okay. The species will be after this. So if we go through the analysis for the manual calculation, provided that the critical part will be to get the summary statistic. To get the summary statistic, right? I mean, first of all, we get the summary for each of these cells. I mean, based on the data set, and then we prepare another summary statistic for overall for the first factor and for the second factor. Once we have got all this, then easily you should be able to calculate for all the sum square total, sum square between, as well as sum square within. Once we get the summary statistic for the overall, summary statistic for the first factor, summary statistic for the second factor. Okay, that will be the crucial part. If you get that done correctly, then the tendency is your calculation will be perfect. You should be able to get the correct answer for the calculation. Okay, so that is based on my observation. The crucial part will be there. But if in the exam, that summary is given, then of course easy for you, is it right? Based on our midterm exam, all the question, we give you the summary statistic, the summary statistic for the data. By right, we should say Alhamdulillah. So in the final exam, if it is in the form of summary statistic, we should also say Alhamdulillah. Okay, so at least the crucial part is done. I mean, it's done, been given in the question paper. So that means the mistake will be less. So that therefore, the tendency for you to get the right answer will be much, much higher. Okay, so what is our time now? The time is 3:30. Okay, let's go for our break. And we come back at 3:50. Then we take about 25 minutes break. Yeah, we come back at 3:50 for SPSS plus SLT4. I mean, we can also use SLT4 in order to run for this example. Okay, so we go for our break. I stop the session for the moment, and we come back at 3:50. Okay, Assalamualaikum. Welcome back to our session. I have already uploaded the data set for the example. So make sure download the data set for our practice on how to run the analysis using SPSS. Malay, have you downloaded the data set?
Yes, Prof.
Okay, good. Others? Haslinda, have you download? Okay. And make sure download and open in SPSS. Kalau download je tak open, tak ready lagi. So make sure download and open your data set in SPSS. Then what we intend to do will be, we want to share how to run the data set for the Factorial ANOVA. And then from there, based on the result, first of all, we want to know the step-by-step procedure, how to run for Factorial ANOVA, so that you should be able to get the result as what we did for manual calculation. In addition to that, we want to make sure that based on the result displayed in the SPSS output, we want to learn how to interpret the result, where to look for the result that we want, and then how to interpret the result. And finally, I will share how to use SLT. And for SLT, we have two variations. The first variation will be, we just enter the data set and it will give you the rest of the calculation as well as the interpretation. And the second variation for the SLT4 will be based on the SPSS result. If you want to get the interpretation from SLT4, we can just extract as what we did for discriminant analysis, extract the result from SPSS and then enter into SLT4. And it will give you the interpretation for the result. Now, Everyone are ready? Anybody still working on the how to download the data as well as to open data in SPSS? Ready? Yes or no? Okay, good.
Yes, Prof.
All right. Okay, now let me open my SPSS. Okay, this is SPSS. Yeah, SPSS. All right. So if you were to open the data set, we have three variable. We have three variable: Y, which is the teacher stress score, and then we have the X1 principal gender. We have one for male, two for female, and then X2 for principal leadership style, where we have one for autocratic, two for democratic, and three for laissez-faire. And if you look at the data set, it comprises 60 cases altogether. 60 cases, the total sample size, the big N is 60. Okay, now, in order to run for this Factorial ANOVA, so what we need to do will be, first of all, we just need to click on Analyze. Click on Analyze. But the next step is not to select from Compare Mean. That was what we have done when we did for one-way ANOVA, is that right? But if you were to run an ANOVA, that means you are limited to only one IV. But in this case, we need to go for General Linear Model, GLM, the next option. And just below the compare means, General Linear Model, GLM, and select for the first option, which is univariate. I mean, if you want to run for Factorial ANOVA, just go for Analyze, GLM, and univariate. Once you click on univariate, and then you get this dialog box. Let me first of all cancel this. Oh, cancel. Patutnya reset, patutnya cancel. Okay, GLM univariate, and then reset. Okay, so what we need to do will be, we have these three variable. Enter Y into dependent variable box on the right. Enter X1 and X2 into the fixed variable, fixed factor on the right. So the three variable, we enter the Y on top, and then the X1 and X2 for the fixed factor, and then click on post hoc. Click on post hoc, and then for post hoc, if it is relevant, it's not for X1, it's only relevant for X2. So just highlight on X1 on X2, and then click on to the right for post hoc test. And then the post hoc test that we want to select will be 2 key, that means 2 key HSD, right? Okay, so enter X2 into the post hoc test, and then tick for 2 key. Once done, click on continue. Once done, click on continue, and then click on option. Click on option. When you click on option button, then you get this dialog box. So select for descriptive statistics so that we can get the descriptive statistic for all the variable, and then select for or tick for estimate of effect size so that we should be able to get the partial eta squared. So estimate of effect size. Okay, once done, simply click on continue, and then once done, simply click on OK. That will be the procedure how to run for this Factorial ANOVA in SPSS. So what we have done just now was we click on Analyze, we click on GLM, General Linear Model, we click on Univariate. Okay, once you open the dialog box, enter the dependent variable, enter the independent variable into the factor, the fixed factor, and then click on post hoc, and then select for and enter the variable that you want to run for post hoc. I mean the factor. So in our case, only X2 is relevant. X1 only 2 category not relevant to run for post hoc. And then once we have selected for the post hoc, which we select for the 2 key, and then click on option. When we click on option, we select for descriptive as well as estimate of effect size. And then once done, simply click on OK. When we click OK, this is our result here. Okay, the first set of our table will be the univariate analysis of variance. I mean the summary statistic. We have the between group factors. That means we have here principal gender. We have 2 categories, male and female, and each category comprises 30 cases. And then for the principal leadership style, we have 3 categories: autocratic, democratic, and laissez-faire. And we have 20 cases for each. And then the next table gives you the descriptive statistic. I mean, for the mean, standard deviation, and N for each of these 7 categories here. And then the next one will be the test of between subject effect. I mean, here will be the one just like what we did for the summary ANOVA table. I mean, in order to establish your summary ANOVA table, this will be the table to look for. All right. So in this case, if let's say now we want to test for the effect of factor 1, which is gender, on teacher stress. Okay. Step number 1 will be we want to put forward the HO/HA, is it right? That means for gender, HO will be mu1 equal mu2 against the alternative hypothesis mu1 not equal to mu2. Step number 1. Step number 2, what is step number 2? If you were to run based on a species output, step number 2
set
is not
alpha.
to we just need to set alpha. Therefore, step number 2, alpha equal 0.05. Okay, step 3. What is step 3?
Report F ratio and significant F.
Okay, we just need to report F and significant F for gender. So in this case, if we look at X1, which is gender here, X1, the F is 12.221. Yeah. Oh, did I share the SPSS viewer or still the SPSS data editor? Let me open the viewer. Okay, so if I were to open the viewer, then you can see on the screen. So if you are testing for the first variable or first factor, which is in this case gender, then in step number 3, where we need to report the F and significant F, for X1, F is 12.221, significant F is 0.001. That will be our F and significant F. Step number 4. Step number 4.
Make decision.
Okay, decision. So in this case, in order to make our decision, what is it that we need to compare? In manual calculation, we compare F calculated against F critical, is that right? But for SPSS, we don't compare F calculated against F critical, but instead we compare
significant F
against
significant
alpha.
F.
Yeah, we just need to compare significant F against alpha, where our decision criteria says if significant F is less than or equal to alpha, reject HO. Significant F bigger than alpha, fail to reject HO. So in this case, our significant F is 0.001, alpha 0.05. So 0.001 happened to be smaller than alpha, therefore reject HO here, right? Reject HO. When we reject HO, what can we conclude?
There is significant difference.
Okay, you can write there is there are significant differences in teachers' stress among teachers working under male and female principal at 0.05 level of significance. Or you can just write as what we did earlier, there is significant mean effect of gender, the principal gender on teachers' stress at 0.05 level of significance. I mean, either or. You can conclude by saying that there is significant difference in our DV among the IV at whatever alpha, or you can just simply say there is significant mean effect of the first factor on DV at whatever the alpha. Right? That means you can present either or. Don't present both. Present either or. The meaning is the same. The meaning will be the same. Okay, that means that will be for factor 1. Okay, if you want to test for factor 2, maybe for factor 2, start with Charlie. For factor 2, what should be our HO and HA, Charlie? Factor 2 is leadership, principal leadership style. So what should be our HO, HA? Charlie, are you ready? Are you ready to share with our members? Your microphone is still off. Microphone off. Oh, Charlie, you want to let others to participate first? Okay, maybe Haslinda. Haslinda, we are testing for the effect of leadership style on teachers stress the second factor. What should be our HO and HA? HO? I can see your mouth moving, but I can't hear your voice. The microphone is on, but maybe the volume is too low. Earlier, I can hear you. Yes, we can hear you. We can hear you now. Okay, HO is? Mu1 equals mu2 equal mu3. What we're saying is mean for autocratic equal mean for democratic equal mean for laissez-faire. Against the alternative hypothesis, as what we did for one-way ANOVA, not all means are equal. That will be step number 1. Nasiha, step number 2. What should be step number 2? If we want to respond based on this SPSS output. Step number 2.
Calculate the test statistic.
Itu calculate tu if this manual calculation. We should differentiate between. We have two approach in testing for hypothesis. In the first before break, we go through manual calculation. That means for manual calculation, step number 1, state HOHA. Step number 2, calculate test statistic. But this is not based on manual calculation, but this one is based on SPSS output. So step number 1, regardless, will be identical. State HOHA, step number 1, regardless whether it's manual calculation or SPSS. Okay, what should be step number 2 if it is based on SPSS output? Nasihat? Kita nak dapat nasihat daripada nasihat ni. What is it?
Significant value.
We just need to set alpha. We just set alpha. Your either in our example just now, we set alpha at 0.05. Therefore, step number 2, alpha equal 0.05. Okay, that will be step number 2. Yong Jing Peng, step number 3. What should be step number 3?
Step number 3 is to find the F value, F significance.
Okay,
Sorry.
we just need to report F and the corresponding significant F, is that right? So again,
yes.
for X2, based on the output X2, the F is 10.612. We just need to report F equal 10.612, and significant F is 0.0001. That will be step number 3. We just extract the two values and we just need to report F and significant F. That will be step number 3. Okay, step number 4. Yang Kun, what is step number 4, Yang Kun? You are watching up in somewhere the scenery outside. Right? Your picture indicate that you are watching scenery outside. So what is step number 2, Yang Kun? Or if Yang Kun is not ready, maybe Leroy. Yang Kun is ready now. Yang Kun, what is step number 4?
Number 4 is 78.050.
Step number 4. Okay, let me recall. For SPSS, step number 1, we state HOHA. Step number 2, we set alpha. Step number 3, we just extract the F and the corresponding significant F. Step number 4. Okay, step number 4. After we have extracted the F and significant F, what should be step number 4? We want to make decision. Okay, now, as what we did earlier for gender, for principal gender, in our decision, we just need to compare significant F for leadership style against alpha. So our significant F is 0.000, is that right? Alpha is 0.05. So now 0.000 happen to be smaller than alpha 0.05. So what should be our decision? Are we going to reject or fail to reject the null hypothesis, Yang Kun? Or maybe if Yang Kun not ready, Leroy, what should be our decision? Are we going to reject or fail to reject when significant F is smaller than alpha?
Decision.
Now we are going to make decision. So what should be our decision? Should we reject or fail to reject the null hypothesis? Pardon me?
Fail to reject HO.
Okay, reject HO, that's right. I mean, since significant F 0.000 smaller than alpha 0.05, therefore reject HO. When we reject HO, Gaussian, what can we conclude based on that hypothesis test? What can we conclude? Or anybody who are ready, what can we conclude based on that hypothesis test? Anybody?
There is significant
Significant
main
main
effect
impact
of
interaction
leader style on teacher stress
DV.
at 0.05 level.
Okay, one way for you to present the conclusion would be there is significant mean effect of leadership style, the principal leadership style on teacher stress at 0.05 level of significance. That will be one way that we can interpret the, that we can make the conclusion. Another way that we can phrase the conclusion will be, anybody? Another way? Malay mentioned the first way. That means we are saying that there is significant mean effect of principal gender on teacher stress at 0.05 level of significance. Another way that we can present the result, the conclusion. Anybody? Charlie, are you ready now? Charlie, I can see your spectacle. Anybody? Yeah, we have here Yong Jingping, we have Faiza, we have Nasiha, we have Charlie, we have Malay, we have Hasilinda. These are our members who switch on the camera. We also have the Big D. Okay, Big D, maybe you want to try to make Big D? Even though you are sit in, you want to share another way that we can make the conclusion based on the hypothesis test. Or anybody? The big D is Dora, because Dora just display the big D. Okay, nobody? Okay, another way that we can present will be there are significant differences in teacher stress among the three principal leadership style at 0.05 level of significance. That means what we are saying is the teacher stress are significantly different among the three teachers leadership style. That means whether they are working under autocratic, democratic, or laissez-faire principle, the difference is significant. The difference in their stress is significantly different. That will be another way that we can put forward as our conclusion. Okay, that will be the second hypothesis that we are testing. Okay, the third hypothesis that we can test. Anybody? What should be the first step? We want to state the HON, HA. Okay, what should be the HON, HA?
Mu IG.
Mu IG equals
mu IG prime.
Okay, that means the null will be mu IG equal mu IG prime against the alternative hypothesis, HA. Mu IG
doesn't equals mu IG prime.
Mu IG prime. That will be step number one. I mean, we are testing for the interaction. Okay, step number two, we set alpha at 0.05. Remember, because in assignment, still we have some of our members, even though the last question is based on species output, but still some are still doing manual calculation. That means if it is based on species output, step number one, state HOHA. Step number two, just set alpha. Step number three, okay, what should be step number three?
Report
F.
Report
okay,
F and
significant
F. That's right. Okay, F and significant F. Is right? Okay. Now, what is our F? F for interaction is 1.417,
417.
1.417, and significant F is 0.251. 251. All right. Okay. Now, based on that, then we should be able to proceed to make our decision whether to reject or fail to reject the null hypothesis. Okay, based on the SPSS output, the fourth step will be decision, whereby in order to make decision, we just compare significant F against alpha. Significant F is 0.251, alpha 0.05. And this 0.251 happen to be bigger than alpha, is that right? When it is bigger than alpha, what should be our decision? Reject or fail to reject?
Fail to reject.
Fail to reject. When we fail to reject, then the conclusion will be there is no significant significant interaction effect on teacher stress at 0.05 level of significance. That will be our conclusion for the interaction. There is no significant interaction effect on teacher stress at 0.05 level of significance. Okay. Okay, that take care for the three hypotheses that we can test based on the result for the analysis. Okay, next will be, if let's say we want to know, if we want to proceed on to identify which group that is or are significantly different, where we proceed to post hoc comparison. I mean, if we go further down for the post hoc comparison, okay, here, multiple comparison, yeah, post hoc test. Principal leadership style is the okay, this will be the for the IV for all the factors that we are testing. And as what we did for one-way analysis of variance, in order to make our decision based on this post hoc comparison, the two key HSD, we can make our decision based on three columns. The first column that we can base for our decision will be mean different column. For mean different column, what we need to look for will be star or asterisk. If there is star or asterisk, that means that indicate that the pair or the two group is significant. That means the mean for the two group is significantly different. But if there is no star or no asterisk, then the difference is non-significant. That will be the first column that we can make our decision. This column here, the mean different I minus J, right? Okay, the second column that we can make our decision will be based on the SIG, significant column. For significant column, we just need to compare the value, the significant value given in the output against alpha. If the significant value is less than alpha or equal to alpha, the difference is significant. If the significant value is bigger than alpha, the difference is non-significant. That will be the second column that we can make our decision. And the last column that we can make our decision will be based on, if we are testing for, we are testing at 0.05, then we can refer to 95% confidence interval. If on the other hand, you are testing for 0.01, then you can test at, you can look at 99% confidence interval. I mean, if you select for 0.01, then the result given will be 99% confidence interval. I mean, in relation to this, the alpha that we set for the analysis. Okay, now, the first pair, autocratic and democratic. For the mean difference, is there a star?
Yes.
Yes, I mean, as what we did for manual calculation, there is significant difference in teacher stress among teachers working under autocratic and democratic leadership style. That mean the difference between the two groups is considered to be significant. And then if we refer to the significant column, the value is less than alpha, therefore also consistent, saying that yes, also there is significant difference. And for the confidence interval, if you can still recall, what is the basis for our decision?
Where is 0?
Okay, we look for 0. If 0 fall in between, lower and upper limit or lower and upper bound, the difference is non-significant. But if 0 is outside, either on the left or on the right, if it is outside of the confidence interval, then we say that the difference is significant. So now, the lower bound is 4.9930. The upper bound is 16.3070. So where is 0? Is it in between or outside?
Outside.
Outside. Therefore, consistent with the mean difference as well as significant column, there is also significant difference in the teacher stress between the two groups, autocratic and democratic. And that will be the first pair. The second pair will be autocratic and laissez-faire. Autocratic and laissez-faire. Is there a star for the mean difference?
Yes.
Yes. The significant value, is it less than or bigger than alpha 0.05?
Less.
Less than
Where is 0
0.05.
for the 95% confidence interval? Where is 0?
Outside.
Outside.
I mean, consistently, based on the three column, the result says there is also significant difference in teacher stress between the two groups. I mean, between autocratic and laissez-faire. And the last pair that we need to look here will be democratic and laissez-faire, between 2 and 3. This is 1 and 2, 1 and 3, and 2 and 3. And if you look at the mean difference column, is there a star?
No.
No star. Okay, that means after all, today is, now is not at 9, is it right? If it is at 9, there is a possibility that if you look outside, there may be star, but now is still daytime, so no star. Okay, significant column, what is the value? Is it bigger than alpha or less than alpha?
Bigger.
Bigger than.
Bigger.
Bigger than alpha. I mean, what we can see here will be a democratic 0.265, is that right? Okay, what about the confidence interval? Where is 0?
In.
In between, right? Because the lower limit is minus, the upper limit is positive, therefore 0 is in between. So that means consistently for the three column, saying that there is no significant difference in teacher stress between the two groups, which are democratic and laissez-faire. That will be how we interpret the result. And if you were to look at the next table, the homogeneous subset, I mean, what can we say based on, what can we interpret based on the homogeneous subset? It's also given from our one-way analysis of variance. You are given the one table called homogeneous subset. What can we interpret based on the result in this table? Okay, if you look at the table, democratic and laissez-faire fall under the same subset, is that right? Fall under the same subset. I mean, what we can say is there is no significant difference in teachers' stress between these two groups because they are within the same subset. I mean, the difference is non-significant. But autocratic fall under different subset. I mean, if you were to compare autocratic and democratic, the difference is significant because they are from different subset. Autocratic and laissez-faire, the difference is also significant. I mean, that is how we can interpret based on the homogeneous subset result table. That means we look at which subset is homogeneous and which subset is heterogeneous. Heterogeneous, I mean different. So in this case, the two group that are homogeneous, democratic and laissez-faire, I mean, no, the difference is non-significant. But for the heterogeneous subset will be between democratic and autocratic and laissez-faire and autocratic, and that will be the heterogeneous. And finally, where to get the partial eta squared? Where can we get the partial eta squared? We need to go back to the summary ANOVA tab. That means the table entitled Test of Between Subject Effect. Test of Between Subject Effect. I mean, for gender, the partial eta squared is 0.185, as what we did for the manual calculation. And then for the X2, which is leadership style, the partial eta squared is 0.282. But for the interaction, the partial eta squared is only 0.050. The interpretation will be similar to the interpretation that we did earlier. Either we want to interpret by size or we want to interpret by the percentage of variance in the Y that is explained by X. That will be what we need to understand, how to run the analysis in SPSS and how to interpret the result, where to look for the result and how to interpret the result. Okay, any question based on the SPSS output that you may want to put forward?
Prof.
Yeah.
Faizah here. Prof, in your notes, you are using the Bonferroni for post hoc, is it?
Okay, that is an option. I mean, actually, there is advantage of using that Bonferroni because when we go for Bonferroni as compared to the this 2-key HSD, Bonferroni they don't test everything at 0.05. Okay, the first pair that the highest and the most significant is compared against alpha divided by, because we have 3 pair, alpha divided by 3. The second highest, alpha significant value compared against alpha divided by 2. And the last pair will be, we compare significant value for the least significant result with alpha divided by 1, which is 0.05. And I mean, it will be more stringent. I mean, if you want to use that, the procedure called Bonferroni, what we need to do will be, okay, follow me. We can request for Bonferroni. We click on Analyze, and then click on the same thing, that means general linear model, univariate, and we get the dialog box as we did just now. And then, can you see this button, EM means? EM means. Click that option. When we click on this option, I mean, in this case, we can also request for the post hoc comparison, where in this case we request for X2, which is for leadership style, and then by default it doesn't compare mean effect. So we just take this option, compare mean effect. When we click on that option, compare mean effect, then by default the procedure that is selected is LSD. But you can select for the option for Bonferroni. Bonferroni. I mean, it is the option is here under this option EM means, and then you just enter the factor that we want to test for the post hoc, and then we tick the option for compare mean effect, and then we select for Bonferroni, and then when you click on this Bonferroni, and then click on continue, and then click on OK, then we get the result here. Here, pairwise comparison. Right? And this will be based on Bonferroni post hoc comparison. I mean, this is the option to be used if we decided to go for Bonferroni for the post hoc comparison. Does that answer your question, Faiza?
Prof.
Yeah. Okay, good. Are there any question based on how to run, how to extract the result, and how to interpret the result? Okay, if there's no question, then we proceed to the next procedure where we want to run this analysis using SLT4. For SLT4, first of all, we just run using the template whereby we just enter the data and we get the result plus the interpretation. Okay, please open your SLT4, but in the meantime, open your SPSS data editor. Just copy the data set. I mean, we don't have to enter the data set manually. Just copy the data set from case number 1 until case number 60. We have 60 cases altogether. Okay, copy. And then open your SLT4. Let me open my SLT4. Okay, if I were to open my SLT4, that means I go to the main page. Okay, you just need to select for the, in this case, Factorial ANOVA. That means without anything, I mean, not we have 10 and 11. Choose the option number 10, Factorial ANOVA, Factorial analysis variant. Okay, you get this, and then just highlight the first cell under Y, and then Control V for you to paste the data set. When you paste the data set, automatically all the calculation is done. I mean, in this case, what you get will be, everyone, have you opened your SLT4? Have you entered the data? And if you were to observe, just below here, this will give you the summary statistics. For the first group, we have 30 cases, and then the summation y, and then this is for the x1 and this is for the x2. And then we also have the summary for the overall, summary for group for factor 1, summary for factor 2, right? And then what we need to do next will be just set the alpha 0.05, and then okay, the hypothesis will be this one. I mean this will be the general hypothesis, and then the test statistic, and then the summary table, summary ANOVA table, and you get where this will be similar to what we did for our manual calculation as well as SPSS. But just one reminder, if you look at the top notes here, this analysis meant for balanced model. That means, what do you mean by balanced model? That means we need to have equal number of cases for each of the group. That means the calculation is based on balanced model. If the number of cases are different for each of for the group, then we cannot use this template, because this template is based on balanced model. So if you have different number of cases for the group, then we just need to rely on SPSS, because the current template that we have is only meant for balanced model. Currently, what we have for this example, we have equal numbers here, right? 10, 10, 10, 10, 10, and then for the second, based on the second factor, 20, 20, 20. I mean, they are balanced model. So if it is balanced model, that means the result that you get here and the result that based on manual calculation and SPSS will be identical. So the same interpretation here. Okay, for factor 1, the 5-step procedure. For factor 2 and for factor 3, the effect size plus the interpretation, effect size interpretation, effect size interpretation, and finally you get here how to. The result will be presented as here. I mean, the way for you to present the result in your thesis or into your dissertation, then you can just present like this. And that will be the table to be presented for your thesis or for your dissertation. Okay, that will be SLT for manual calculation. I mean, we just enter the data, it complete the summary statistic, the calculation, and then also the interpretation for the result. Okay, and then what we need to do will be how to use the second template. I mean, if you go back to the mean, and then select the option for factorial analysis of variance, SPSS. I mean, if you were to choose that option, we just need to enter sum square and degree of freedom for the factors. Okay, need to charge my battery. Oh. Okay, now open the template for SPSS. I mean, the Factorial ANOVA is for SPSS. You get this template. Okay, now what we need to do in order to get the interpretation for the result, we just need to copy sum square degree of freedom for the 2 factors plus error. 2 factors plus error. So we just go back to SPSS. Open your SPSS. Let me open my SPSS first. Open SPSS, and we just need to copy the sum square. I mean, the sum square will be from here. So here, sum square. Plus error. We just enter the error together, and then we move the error to the right place. We just copy this, the sum square and degree of freedom, and go back to SLT4. Go back to SLT4. Oh, tadi saya tak share. Go back to SLT4, and then just okay, SLT4, and then paste here. Oh, better to use paste the option here. And here, mesh destination formatting, right? But we need to no, we need to enter this one. This will be for the error, and then copy, and then paste here. Satu je. Just copy and then this. Okay, that take care of this, and then this one you can remove, and this one is actually for the interaction. Just copy, and then for the interaction, and then you can remove this. Okay, so that will be the sum square for x1, sum square for x2. x1 will be for gender, x2 will be leadership style, and then x1 and x2 will be the interaction. Error will be the within sum square as well as the degree of freedom. Okay, now having entered that, and then we just need to set alpha, let's say in this case 0.05. Okay, now we select which factor that or which effect that we want to test. So now we can select from here. Let's say we want to test for gender. So you just click on X1, which is gender. So the null hypothesis will be for gender, that means HO, this is just gender. So that means the specific will be mu1 equal mu2 against the alternative hypothesis, mu1 not equal to mu2. Confidence level, alpha equal 0.05. And then F statistic will be 12.221, and significant F is 0.001. And decision, since significant F is smaller than alpha 0.05, therefore reject HO. When we reject HO, that means there is significant mean effect of X1 on Y, which is in this case teacher's stress at 0.05 level of significance. And then if we were to go to the effect size for X1, which is gender, the effect is partial eta squared is 0.185 and considered to be large effect size. Okay, large effect size. Okay, that will be for factor 1. If you want to test for factor 2, just select for factor 2. And then for factor 2 will be hypothesis HO, mu1, because we have 3 categories, mu1 equal mu2 equal mu3 against the alternative hypothesis, not all means are equal. Confidence interval alpha equal 0.05. Test statistic F equal 10.612. Significant F is 0.000. Okay, decision. Okay, now similar to what we did earlier, since our significant F 0.000 is smaller than alpha 0.05, reject HO. When we reject HO, what can we conclude? There is also significant mean effect of X2, which is in this case, principal leadership style, on Y. What is our Y? Teacher stress at 0.05 level of significance. And if we proceed to the effect size, for the effect size is 0.282, that means the partial eta squared equal 0.282, which is considered to be also large effect size. Okay, and if you want to test for the interaction, so you can just enter the option here for the interaction x1 and x1 by x2. Then you get the hypothesis, the alpha, and the F is 1.417, and significant F is 0.251. And decision, since our significant F is bigger than alpha, therefore fail to reject. When we fail to reject, I mean the conclusion is there is no significant interaction effect of x1 on x2, the x1 and x2 on Y, which is teacher stress at 0.05 level of significance. Okay, and then for the effect size, if you look at a little bit down, the effect size, the partial eta squared is 0.050, which is considered as small effect size. Okay, and then the presentation for the result will be here. That means you just present, you remove the space in between. So you just continue x1, x2. That means x1 will be gender, x2 will be leadership style, interaction, and then error, total, and then all the rest. I mean, you have sum square, degree of freedom, mean square, F, and significant F. That means that will be the purpose of using this template, where if you get the result and you don't have any, you want to confirm whether your interpretation is right or wrong, then you can go to this template, just extract from the SPSS output the corresponding sum square and degree of freedom, and then you can proceed to test for the individual effect for, if in this case, in our example, effect for factor gender, effect for leadership style, and effect for the interaction. That will be what we can utilize for SLT4 in order to help us to reinforce our interpretation for the result. Okay, that basically cover what we need to cover for this session. which is on Factorial ANOVA. Unless if you have any question, then we can try to respond. Otherwise, that will be the end for our session. Okay, Dora, how are you? Now I can see you. Earlier I can see the big D. The big D can be Diana, Princess Diana. Okay, this is Dora. Okay, I open for any question, for inquiries, or for any question to be further clarified. Anything? Happy with the topic?
Yes, Prof.
Yeah.
No question.
Yes, Prof.
Okay, if
We're
you are happy, then
Yes.
everyone happy?
Yes, Prof.
Okay, if you are happy, then that's it. That will be what I can share on Factorial ANOVA. So what we have discussed just now was we can see the difference between one-way analysis of variance and Factorial ANOVA, which constitute two-way, three-way, four-way, and whatever way. I mean, the number of ways here refer to how many factors that we are testing. Factors here refer to your independent variable, categorical independent variable. If you have only one categorical independent variable, you call that as one-way analysis of variance. If you have two independent variable, you call that as two-way analysis of variance until whatever number of ways of the, and this two to whatever number of ways we combine together, we call that as Factorial ANOVA. The beauty about Factorial ANOVA as compared to one-way analysis of variance, in addition to testing for the mean effect, we can also test for the interaction effect here, right? If it is the previous version for SPSS, when we run for one-way analysis variance, we will not be able to get the effect size, the eta squared. But when we run under, when we run under Factorial ANOVA, we are given the option to get the partial eta squared. So last time we have to calculate the eta squared, but now if you are using version 27 or more or higher, higher will be 28, the highest, the latest will be 28, then you have the option to request for the effect size. Okay, so make sure by now you know what to expect for Factorial ANOVA and know how to run for the manual calculation, and then know how to run the Factorial ANOVA using SPSS. And to further reinforce your learning, we can also utilize our SLT4. Okay, so if that's the case, no question, happy, then thank you very much. Inshallah, we meet again next week for
Proof. I have a question.
This is not, oh, you are stopping the bus. Yeah.
Yes.
Young
I have a
Ping,
question.
stopping the bus.
Yes.
Stop. Yeah, okay, now the bus is on hold. Okay, bus. Okay, what is your question?
Okay.
Young?
Well, it's about our final examination. I think it's quite important for all of us. Yes. I just want to know, as to the calculation, we have to finish it manually, or we can, calculate through SPSS or STL4.
Okay, remember as what we did for our midterm exam, if it involves manual calculation, you are not supposed to use SLT, you are not supposed to use SPSS. I mean, if it is manual calculation, manual calculation, just rely on the formula sheet. I mean, you need to do the calculation. But you will be lucky if you are given the summary statistic. That means the summary data. That means you can just proceed from that. But if you are given the raw data, as what we did from our exercise just now, that means you have to do the calculation from the beginning. But most probably you will be given the summary data. So don't worry,
Okay.
It is to your advantage. You don't have to start from the beginning. That means you are given half-cooked data. That is what I call as half-cooked. That means you can just proceed with the calculation without having to go through to calculate the basic statistic for each of the classes and so on and so forth. Right? So does that answer your question, Young? Don't worry.
Yes, good. Yes.
The exam will be a few weeks from now. A few weeks from now.
I'm quite nervous because of the first exam.
The midterm
right?
exam. I'm sure this time everyone should be able to perform much higher, inshallah. Okay?
Okay,
Be
thank
happy
you.
and be confident, inshallah. Everyone will be able to perform better this time for in our final exam. Okay, so thank you very much. We meet again, inshallah, next week, the same time, 2 to 5. Okay, Assalamualaikum
Thank you.
warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi. Thank you.
Thank
Prof.
you.
Okay, welcome.